All right, let's go ahead and get started. I have quite a few slides to get through. A lot of stuff I want to try to cover today, so we'll get started, and I'm sure other people will be trickling in as we go. Before we jump into it, though, I'd like to get a little sense of people's familiarity with OData today. By the way, this talk is about OData. Hopefully you knew that and weren't just finding a room to sit in to eat your snacks. So how many people have some familiarity with OData? You've heard about it, you've kind of know where it's used, how it's used? A couple people. Has anyone implemented an OData service or consumed an OData service? Okay, great. We're all in the same boat then. No, my name is Mike Pizzo. I'm an architect in the Microsoft Applied Technologies group, and for the last more years than I'd care to admit, I've been working on data access technologies at Microsoft. So I worked on ODBC back in the early days, and OLADB, and ADO, and ADO.NET, and so any issues you've had with any data access technology, they're all my fault, and I apologize in advance. The last few years I've been working on OData, particularly on the version 4 of OData and the standardization of OData through the OASIS standards group. And we'll talk more about that when we get into the slides. We actually have 4 talks on OData, so I hope you're excited by this because we've got 3 more to go, or you're going to have to find someplace else to eat breakfast tomorrow. We've got 2 talks this afternoon. The first is an OData overview, and it sounds like that'll be a good overview to kind of give you guys sort of the gestalt of 30,000-foot view of what OData is all about. Hopefully that'll interest you enough to get into the OData deep dive. The OData deep dive we'll go through, and there's no way that at the end of the deep dive you will have memorized all of OData, but my goal is to have you guys have seen enough OData that you're familiar with how it works, you've got the concepts, you understand sort of the thinking behind it, and so that when you look to implement it or implement queries against it or even talk to your peers about it, you've got a deeper feeling of what OData is all about. And then tomorrow morning, we'll actually get into implementing OData. If you've got an interesting data source and the first 2 sessions have inspired you to try to make that data available to other people to consume, like Excel, we'll talk about how you can do that. And the second part of that is actually figuring out how to validate the service that you've written to make sure it's going to be interoperable. So there's a lot of stuff to cover. Let's go ahead and jump into it. The first talk is the shortest of the talk. We're going to start with just a very high level, what is OData? What are kind of the high-level features that it has? What's the status of OData? How has it evolved, and where is it now in the standards? Talk a little bit about levels of conformance of an OData service, and then a little bit, for those of you who may have been familiar with OData in the past, what are some of the new things we have in OData version 4? So let's jump into it. At a very, very high level, OData is really an interface for interacting with data. It's a web interface. It's HTTP based, so that gives it a broad reach and a general applicability that makes it very nice for interoperability scenarios. But it really is a web-based protocol for interacting with data. So for people who are familiar with ODBC, I've often described it at a very high level as ODBC for the web. It turns out it's a lot more than that, but that'll kind of get you at least in the right ballpark. So what does that really mean? What does it mean to be an API for sharing data on the web? Well, it really came out of observing some trends that were going on in the industry. So the first thing we saw was that data was moving more from siloed, like data being owned by and specific to a single application, to data being shared across multiple applications. And even sharing the data became more interesting in many cases than the applications themselves. So there was this move to open data, and that was true in enterprises. It was also true in governments, where governments were starting to be mandated to open and share their data, as well as science and other industries. So there's this move towards wanting a real desire to open up data. There's also a growing trend to move more and more data and processing and services and so forth from on-premise to the cloud. And as data in particular was moved from on-premise to the cloud, it became necessary to have APIs that allowed you to work with the data both on-prem and in the cloud. We saw a growing trend from web-based data where people were interacting with with data on websites to a world where machines were interacting with the data through web APIs. So you take something like Twitter. Twitter has a web application, and you're probably all familiar with it. You can go in and you can enter your tweets and read tweets and so forth. But the bulk of the interaction to Twitter doesn't come through their web application, but through their interfaces. So there's this growing trend to move from a human readable and interaction style to a machine readable interaction style. And that was driving a change from things like SOAP-based APIs to more things like REST-based APIs. So rather than have APIs that were designed for a specific purpose that were fairly specific to a single applications and how that single application was consuming data, it was moving more towards a world where the API followed the data and the applications can interact with the data in ways that weren't envisioned when the data was exposed. And so we saw this RESTful programming pattern appearing. And so that was all great. All of these things were movements towards opening up data. There was a desire there. There was a foundation there. There was a trend there. And there were even programming patterns that were lending themselves to that. So why do we need OData? Why are this not enough? Well, what was lacking was interoperability. So even if you go to REST-based programming patterns, and if you said everybody who has interesting data, Facebook, Netflix, Twitter, everybody else, exposes that through RESTful APIs, you don't get any interoperability. You don't have the ability for a single tool like Excel to query all of those different pieces of data. You can't have a single toolkit integrated into Visual Studio or Eclipse or your other favorite development environment access that data and have a common way to do it. In order to work with a RESTful API, you need to know the resources that are exposed by that REST API. And so if you go to something like Programmable Web, they've got tens of thousands of interfaces that are RESTful interfaces, but there's no way you could write a single application that would work against all of them with any understanding of the data or be able to model the data. So the first thing that's missing is a description of the resources. The second thing we find is that just identifying resources and being able to post, put, get, and delete those resources isn't enough. Where those resources represent large collections of data, typically people want ways that they can filter that data so that they bring down just the subset of the data that they're interested in. REST doesn't define any patterns for that. So each of the different RESTful APIs on Programmable Web that have gotten to any level of maturity have their own ways for filtering out the set of data that you're requesting in a particular web request. Formats of the data returned from those services is not at all standard. So it used to be XML and Atom were a common way to return data. JSON is becoming more and more of a common format for returning data from those RESTful services. But even Atom and JSON aren't rich enough to represent the additional information that you would need to build a protocol on top of those data payloads. So given that, what is OData? Well, OData is really nothing more and nothing less than a set of conventions built upon those RESTful principles and common formats for sharing data. And agreeing on those conventions gives you the interoperability that is lacking today. So the first thing we do in OData is we start by defining a uniform, consumer-oriented description of the resources that the REST interface exposes. So now you can go up to a service that you've never seen before, and you can ask it, what are the types of resources that you expose? What are their properties? What are the relationships of those resources to other resources? And now you start to understand how you can interact with that. The second thing that we do is we define a set of uniform operations using REST principles on those resources. So how do you use put, post, delete, patch to interact with those resources following REST principles? But then we go beyond that and we define conventions for URLs and for query options for doing things like navigating the path, the collection of resources that are exposed by the service, for querying, filtering, sorting, and so forth, those resources. So we start to add more semantics, common semantics to the service that we're exposing. So those really give you the contract with the service. The patterns around RESTful interaction, the conventions for URLs, and understanding the resources that are exposed by the service, those three things together give you the contract with that service, similar to how WSDL would give you a contract for a SOAP service. But this contract is much more flexible in terms of how you now interact with the service that you can understand based on these principles. The next thing we do in OData is we define a uniform way to represent the data payloads, whether you're providing information for a resource you want to create or querying the service in order to get resources back. And we define two formats, a JSON format and an XML-based Atom format. We go beyond just the basic metadata and data instances with an extensibility point called annotations or vocabularies, and we'll talk more about those in a little bit, that allow you to extend and enrich your service in well-defined ways. And finally, we've taken these conventions and these, the way to model the resources of the service and so forth, and we've progressed those through a standards body. And the OData specification, the OData version 4 specification, was approved as an OASIS standard in February of this year. So it's a real standard. It's got other people really pushing behind it. All right. So that's kind of a high level. What are the components of it? What does it really look like? And I want to do just a very, very quick demo because I know that I understand things better when I see them in person. So several years ago, and this is based on an earlier version of OData, Microsoft put together an Open Data Government initiative. And basically what it provided was a toolkit that governments could use to publish their data. And that toolkit built a data platform using OData as the interface for exposing that data. So a number of different government agencies have picked that up and have started exposing their data using that platform, and now that data can be consumed through OData. And so to pick one, honestly, at random, here's the city of Medicine Hat, which is in Canada. And for some reason, Canada has been a big supporter of OData. We think it's because there were some Canadians on the team early on. City of Medicine Hat has decided to make some of their data available as public data. And this is a site you can go to. It's a public site. And it tells you sort of the developer guide, how do you query the data and so forth for those who aren't familiar with OData. You can go see the data catalog, which will tell you the different sets of data that are available. For some reason, I have a really slow internet connection today. And then you can kind of query the categories here. You can select individual classes. So this is all sort of a... Pardon? Can you make the font bigger? I can try. There's probably some nifty way to do that in Windows, isn't there? I can just do this. Is that better? Okay. So I can just kind of go through this, and there's kind of an interface for users to interact with the data, to browse through the data, to build simple queries against the data. So users can use this in order to do kind of quick and dirty things. But the more interesting part is this right here. And this URL is the URL to this particular data set, the available classes data set. So if I paste that into my address bar, I can go and I'll see the, and I don't know why, I can see this is the actual OData feed that is sitting behind those available data classes. But before we get to this feed, let's pop up one level and start out with the service document. So the root of every OData service has a service document, which is an Atom pub service document if you request application Atom SVC, or we also have a JSON format of this service document. And that service document describes the collections that are available in this service. So this says that there's a collection of event locations, available classes, burial listings. These are all the same things that we saw when we went through the user interface. But this a machine can come up to and can use to now, in a hypermedia-driven way, just follow links and explore the data. So this tells the data sets that are available. The second thing we'll see, and we'll describe more of what's in all of this in a minute, or a little bit later. Every OData service also has a /$metadata endpoint, and that $metadata endpoint is the description of the classes that are exposed by the service. So these are the resources that the service exposes. And so a tool like Visual Studio can go up to this and can understand the classes and can generate client-side classes that people could use in order to now build link queries and have a very strongly typed experience in interacting with this service. So this tells us what are the resources that are available on this service. And then I can go to available classes, and I can start doing things like filtering for departments, filtering for all classes where the department is aquatics. And I know that's hard to read, and we'll have some query examples later that give you a better sense of what those URLs look like. But now I can start doing queries against this data, so I bring down just the set of data that I'm really interested in. So that's a very quick demo just to give you sort of a little bit more familiarity with OData and what it looks like and what it feels like. Where's my clicker? There it is. Mm-hmm. Yes. So the question is about the entity model that sits behind that schema that I showed that represents the resources, and does it support inheritance? And the short answer is yes. The longer answer is we'll actually drill quite a bit into the entity model and what it looks like and its characteristics. And right now, let me get back to my presentation. There we go. All right, so where is OData used? Well, really anywhere there's interesting data with some interesting structure to expose, you can use OData. So this is true for particularly in governments where they're trying to advertise everything from bus schedules to crime statistics to flight statistics to whatever else you might want to publish. It's interesting in enterprise where you've got data that you're trying to publish or share. It's interesting in the commercial industries where you've got data that you've curated and now you want to sell that data even in a data market. It's interesting in the consumer space, healthcare, for custom data sources. I actually, I volunteer as the head of the parents group at Microsoft, and I organize all the activities that we have, and we have a lot of activities for different speakers coming in on different topics and talking about whatever parent-oriented thing. And when I kind of took over these sessions from HR benefits, they had a series of sessions set up that we paid, I think it was $190 per session just to have a registration on the Microsoft Learning site. And we had a very limited budget. That was actually more than we had just for the sessions that we inherited. So I wrote a quick tool, and it was just a web tool that went up and queried a database and exposed the data. And so I built an OData service over it, and it made for super rapid development of my application because I could just go in and add a property to this database and then expose it in my web service, and now I had a very easy way that my web-based application could query that data. So custom data is another very interesting area where it just makes it easy and actually kind of fun for us geeky folks to write data-oriented applications. So why do people use OData? What would compel them in these different areas to use OData versus building, and people often ask me, what's the biggest competitor to OData? And I think the biggest competitor is really roll your own. When would I use a custom REST interface versus when would I use OData as a REST interface? And what I generally tell people is OData is a RESTful interface. If you design your own, you're going to face a lot of the same things that there's hundreds of thousands of man hours now in the OData protocol thinking about how you resolve. So how do you model your data? How do you represent the results? How do you deal with large results that span multiple requests? How do you deal with all of these things? We spend a lot of time thinking about them. So if there's not a significant overhead to using OData and there's a benefit to using OData, then the cost-benefit ratio should pan out. So what are some of those things that you get when you use OData over building your own custom REST API? Well, the first is OData, because it has standard conventions and is an interoperable API that other tools can work with, it helps unlock that data. To some extent, if you're exposing your own custom REST API, you're also unlocking the data, but you're unlocking it in a more specific way where the tools and applications that you're writing understand how to interact with it, but you don't get kind of the ecosystem benefit. It extends reach, again, because OData's a RESTful API, because it's built on HTTP. It can be consumed from any device, anything. My home thermostat has basically a web service on it. So anything has a HTTP stack, and anything with an HTTP stack, you can develop an OData service on. It takes advantage of this consumer-oriented conceptual model. So one of the nice things about OData is by being very regimented in how it describes the resources, it makes it very easy to go up to that service and understand for clients to understand how they interact with that service. And now there's a bunch of rules that fall out of that structure that make it easy to sort of think about how you model your service, and then easy for clients to understand how to interact with those services. Rohit was here yesterday talking about the new RESTful interface for Exchange, which is an OData version 4 interface. And we spent time thinking about, all right, how do we model as entities and relationships the interesting pieces of information that somebody would want out of the Exchange store? How are the calendars modeled? How are the mail modeled? How are contacts modeled? What are the interesting relationships? What are the interesting properties? And that discipline in thinking really helps sort of shape the API. In spite of the fact that there is this strong, and these two are going to seem almost contradictory, but they're actually not. In spite of the fact that there's a strong way to represent the resources that you're interacting with, there's still a loose coupling between the client and the service. So one loose coupling is the fact that the interaction of the client with the service is against the data model and not methods, not specific APIs. That would constrain the sets of data that are returned and the input parameters and so forth. But even beyond that, even for the resources that are described by the service, there's a contract from the very beginning between the client and the service that the service is allowed to return additional properties that aren't advertised in metadata. And there's a well-defined way that services do that, and a well-defined way that clients can interact with that, so that services can evolve and clients can continue to interoperate with those services without breaking. And in fact, services can expose some structured data that's reflected in their metadata, but can also expose different properties. And there's semantics and rules around how clients interact with the data that help make sure that, for instance, data's not lossy when you go back and make updates to that data because there were properties that you weren't aware of when you wrote your application. So there is actually, despite the fact that this conceptual model helps the client understand how they're going to interact with the data and can provide very strongly typed experiences when working the data, there's also a loose coupling that allows a very dynamic relationship because it's based on a lot of rules about how the client and the server interact. The OData v4 specification in particular is a very rich and very mature specification. And there's an ecosystem being built around that you get if you implement OData versus your own custom API. So there are libraries for .NET, for Java, for JavaScript, for iOS, just about any platform and any language. There are libraries that help you use OData. Now, those, of course, aren't necessary. You can go directly to an HTTP, make the request, and bring back the results. But those libraries kind of encapsulate some of the rules and some of the knowledge about the conventions of OData to help you more rapidly develop your applications and your services. And then there's also tools and applications. So Tableau knows how to read an OData service and do analytics on top of it. Excel knows how to read an OData service, as does Power Query. So Power Query allows you to build queries against your OData service, bring the data into Excel, and then do rich analysis within Excel on that data. So those are some of the reasons that people might want to use OData. Okay, let's drill a little bit more into the entity data model, and this is getting to some of the questions that were asked earlier. When we describe the resources, what does that mean? When we thought about describing resources we thought about modeling the resources, modeling the data of the service in a consumer-oriented way. That is, rather than pick something like the relational model where you have tables and fields, which was really designed from the beginning as a storage model, not as a user model, we picked a higher level conceptual model of entities and relationships with those entities to other entities. And we picked that because that's kind of how we think about things in the real world. We think about these chairs being in this room. So there's a relationship of these chairs to this room. We don't think about the chairs having a foreign key property to room that corresponds them there. So we picked an entity relationship model. Entities are named structures with keys, and to the question before, they do support inheritance. The structure, they can have structural properties, which may be strings, integers, Boolean, datetime, spatial data types, enums. So there's a fairly rich set of data types that a property can be. A property can be a collection, or it can be a complex type, or it can be a collection of complex types. A complex type is just a name structure that has no key. So it's not directly, you can't directly reference it, but you can group together properties of an entity into a complex type. A common example of this would be like address. So a person has an address, and the address has city, state, and zip, and street address, rather than a person having separate properties. It just makes it easier to deal with the objects that are being represented. As I mentioned before, entities can have dynamic properties. In OData version 4, any entity can return additional properties, and there's semantics with how those additional properties are represented in the payload, how the client can understand the types of those, how they can go get additional information about any types that they haven't seen before reading a particular payload. And then semantics around updates. We promote the use of patch rather than put as an update verb, because the semantics of patch are such that properties that aren't specified in the payload are unchanged, versus put, which is a replace operation, which says that if you don't specify certain properties, they're set to null or the default values. You can also have open types. An open type basically means not only might you get additional properties back in a payload, which is always true for a type, but this type is prepared to persist additional properties. So you can, on a particular instance, almost like a property bag, add additional properties, and the service will store those and return those for you. Now, the interesting thing is dynamic properties and open properties on the wire look exactly like regular properties. And this allows for a looser coupling between the client and the service. And the OData v4 specification has specific rules around what you can change in your data model that is a compatible change that doesn't break existing clients. In addition to properties.
About that a little bit more. So
yeah.
How does the client and server know? How do they sync on these things?
So there's a few different things. So The payload is to a large extent self-describing. So from looking at the payload, it will tell you this is a string, this is a, well, certain properties are obvious from the particular payload format. So in JSON, you understand that a string is a string and a number is a number. Then you can understand from the metadata, and there's a pointer from the data to the metadata that says, here are the properties that I've advertised. So we don't need to tell you what types those are. For additional properties that may occur in a particular instance, there's a way to annotate that property with the type of the property if it can't be deterministically determined. There's also, we have metadata versioning in OData version 4. So when you get back the URL, when you do your initial request for metadata, you can get back an E tag, and you can use that in a subsequent request to see if anything's changed if you need to refresh. So there are some clients that are very metadata aware. So for instance, I mentioned before in Visual Studio, you can go to add service reference for your project, and you can point to an OData service, and it'll generate classes based on that dollar metadata. And then you can build link queries and have a very strongly typed experience. If the service adds additional properties, that won't break you, but you won't see them available. With the version metadata, we could actually pop up something that says, hey, there's additional properties that you may want to access.
One more question.
Yeah.
The keys are unique within the model?
The keys are unique within the sets that a particular instance lives in. So a particular entity instance is identified by its key within a particular set.
Okay. The inheritance model, does it offer something like aspects or interfaces, or only real inheritance?
That's an excellent, excellent question. Versions of OData 1 and 2 purely had inheritance. In version 3, we added something called vocabularies. Vocabularies, and we'll get to this in a little bit, but basically they add the ability to, they really let you do two things. One is they let you extend the metadata with your own annotations. And the second is they allow you to correlate a particular entity with a particular ontology. So you can say, I called this film, but it's what the schema.org creative works would call a movie. And so you can do, and here's how properties of one thing map to properties of the other. So there are ways that you can start assigning common semantics from common shared schemas to your individual data items. What we don't support today is something similar to interfaces in a programming language. But we have all the tools necessary to do that. And so I actually have a proposal sitting on my laptop for a single vocabulary term, and again, vocabularies are a means of extension that we'll talk about in a little bit, to say that in addition to this type being this type, it can also be treated as this other type. And OData has semantics for how you cast a type to another type, how you deal with that in your URLs, how it is returned, and so forth. And all of those rules apply equally to this idea of implements. So we're this close to actually having really what I would think of as interfaces, and that's something that Visual Studio would then understand and generate interfaces for those types of types.
And another question, are there some predefined or commonly known entity data types, so that if someone exposes, for example, some contact persons, that I can, or a client who knows that this is a person with a telephone number, name, first name, and so on, knows how to handle it?
So that's another great question. And the answer is we've laid the framework in OData version 4 for sharing schemas. So a shared schema is basically, we didn't want to go through and define these are all the different schemas. That was I don't know if you were familiar with WinFS. Which was a project Microsoft worked on quite a while ago. And one of the things it tried to do is schematize things, to say here's a schema for contact, here's a schema for mail, here's a schema for this, that, and the other thing. Rather than try to take that on within the OData team, what we tried to do is to find the facilities for somebody, whoever the expert in a particular vertical is, to define a schema, and then a way that your OData service can reference that schema and say, I implement this type, and I have a set of this type, and either you can directly use that type, and the client knows when it goes to your service, it understands that type, or you can say, the type that I use can be mapped to this common industry type. The idea then is to work with organizations like schema.org, and I don't know if you're familiar with schema.org, but it's a group from Google and Yahoo and Microsoft initially, and now there's a few other players in it, who are basically trying to schematize. Initially it was schematizing consumer-oriented data, the type of thing that you would search for. But they're expanding out to schematizing other types of information as well. So the idea is that we'll define schemas for OData schemas for all the schemas in schema.org and use them as the experts and defining what those different types should look like. We'll define the schemas, and then services can just reference those schemas directly. So kind of a long-winded answer, but it's a great question.
Two questions. One, that list of data types there is pretty short. Is that sort of a subset, or is it really intending to?
It's kind of an abbreviated set, so there's multiple different integer types and so forth. We also have something called type definitions, which are like kind of like user-defined types. But is there a particular type up here that is missing?
Like binary data or images, that kind of thing?
Yeah, there are streams. I should add that. Yeah.
My other question is about performance. Is this intended, because it's running over HTTP, to be used for small data sets? If you're querying large data sets, you might end up with that bogged down connection.
So the idea is that the results that you get back are the right size, are the set of is the set of data that you're interested in. Typically on a so it's not intended for large-scale data transfer, but it's intended for potentially very, very large. I won't call big because that's overused in the data world, but very, very large data sets where an individual consumer is interested in a reasonably small subset of that. So they can filter it, they can narrow down the fields that are returned if there are binary fields and they're not interested in those binary fields. And then we'll see later if we ever get off this slide, but that's all right. It's great discussion. One of the things that the TC is working on right now, when I say TC, I mean the OASIS Technical Committee, is working on right now, it's an aggregation vocabulary. So the idea is to push most of the work to the service so that the set of data that you're bringing down, even though it's over HTTP, is a reasonable size set of data. So we've got entities. Entities have properties. Entities have relationships to other entities, and those are modeled as navigation paths or navigation properties. And once you have navigation properties, there's rules around what that means to your URL space, what that means to how you navigate between the data, what your results look like, and so forth. One of the things that we added in OData version 3 is the concept of actions and functions. Once OData was starting to gain popularity, we started talking to some of the people that were implementing OData. And we found a recurring theme, not in every case, but in a surprisingly large number of cases, where people were actually implementing two services. They're implementing an OData service as the way to query the data and have these very nice interaction patterns for getting data and even updating data, but they also had procedural logic. And while you can model procedural logic as resources and gets and posts to different resources where the resource is the state of the machine or state of the system, it's not always the most convenient. And so what these services were doing was they were implementing an OData service for interacting with the data and then a side-by-side SOAP service for executing operations, for workflow operations. And so we added to OData the idea of functions and actions as an extensibility point and also as a way that you can, in a single service, have both those sort of workflow operations as well as your data. Now, if you are a REST purist, HateOS purist, HitOS stands for hypermedia of the hypermedia. Forget exactly, but it's something about hypermedia as the state of the machine. It's not really that they hate OS, although they may. But if you're a very strict RESTful person and you want to model pipeline operations as resources and states on those resources, you can do that. If you want an API, so like an Exchange, Rohit was talking yesterday about the fact that the Exchange OData service has a send mail operation. That's a send mail action. It's very nice and convenient to expose that as an action rather than have to post a mail message to the send resource in order to do a send. So entities have properties and relationships, and an OData service has an entity container. An entity container has sets of entities, and then it can also expose functions and actions. And we'll talk a lot more about that in the next session. Some of the high-level features of OData, there's this metadata discovery, and we saw that with the City of Medicine hat, in the ability to go through and walk up to it and say, what are the collections you expose, and what are the types you expose. There's fairly advanced query functionality, and this is a non-exhaustive list, and in the next session, we'll go through and dig a lot deeper into what are the query semantics of an OData service. There's custom functions, which we just mentioned. There's deltas and change tracking. So one of the new things in OData v4 is the ability to go up to a service and say, get me that data, and then a later time to go back to that service and say, tell me what's changed. And so this starts to address some of the scenarios that you were talking about with large sets of data. One of our early OData data sets was a Netflix library. And there used to be, before Netflix shut down sort of their programmatic interfaces in general, not just their OData interface, but there used to be a way that you could write OData queries against the Netflix catalog. And in fact, I used that when I was searching for a movie because it was a lot more flexible in how I could query the Netflix database for movies than what I could do through the web application of Netflix. And then oftentimes I'd just get geeking out on how I was querying the movies, and it would be too late for a movie by the time I finally got to a movie. But it was really fun exploring the catalog in these nice dynamic ways. But they had, I think it was 175,000 titles at the time, of which every couple days there'd be one or two changes. And we had a service on Azure that would read that catalog and build this nice, very visual, interactive tool for interacting with that data. And every night, it would fetch all 175,000 titles. And it was 3 gigs of data, and it would take something on the order of a couple hours to read all of that data and build this cache when only 1 or 2 things had changed. So deltas gives it the ability to go and say what's changed and get just those 2 records immediately rather than having to download the whole 175,000 records. Yes. No, it was really unfortunate because when I talked about OData, everyone knew Netflix, and I could just point at that and start doing it, and I'm like, oh, okay, I know what OData is. When they backed away, we're like, well, is it us? And it really was a change in policy where they didn't want to make that data publicly available. Okay, we've talked about vocabularies a bit, and we'll talk about it. We'll have some examples about it in the next session, so I'm not going to go in any detail. But just to say, again, a vocabulary is nothing more, nothing less than a set of shared annotation terms. And those annotation terms can annotate both data and metadata. And sharing those as a vocabulary allows you to do things like having common ontologies. We talked about a little bit of the extensibility of OData. One of the nice things about OData is it is a very extensible API in addition to returning additional properties in our advertised metadata and the loose coupling that provides. services, there are rules around extensibility so that services are able to add additional headers or custom preferences or custom query options. And there are rules around how to do that in such a way that they don't conflict with the OData built-in semantics and disrupt things for an OData client that's a generic client and doesn't understand those things. Customs actions and functions are really powerful integration or extensibility mechanisms that allow you, for instance, functions allow you to extend the query space. And metadata and instance annotations are a great way to basically extend the metadata, add additional information about the service that isn't defined in the terms that we have for metadata today. And I may end here with the first part so that we have time to jump into the next part. But I want to talk a little bit about the process of OData and where it is today. So OData started as a labs project at Microsoft. And from the beginning, we were very open with it. We published as a blog, all of our early design discussions and design notes and solicited input. We propped up a service and said, hey, go hit this thing and give us your feedback and tell us what you think. So, and it's always had open licenses associated with it, so anyone can use it, anyone can do whatever they want with it. Maybe not whatever they want with it, but very open licenses. And so we developed versions 1 through 3 through this open process. And even though it was very open, and even though we solicited input and so forth, there were certain government agencies and certain corporations that were unwilling to use OData because it was still perceived as a Microsoft thing. Also, we were kind of limited in the input that we had gotten, and we wanted to broaden the involvement. So about 2 years ago, we brought OData to OASIS, which is a standards consortium. And we formed a technical committee there, and we started working on the OData standard there. And as I mentioned, it was, whoops, this is an old slide. It was ratified as a OData, as an OASIS specification in February of this year. And the next step, the next step is to take that OASIS specification. One of the reasons that we went through OASIS is a direct contributor to ISO. So the next step is to take that OASIS specification, submit it to ISO, and get it as an approved ISO standard. In the meantime, the OData Technical Committee is working on defining some interesting extensions for aggregation, which I mentioned before, which again is trying to make sure that you can work with very large data sets by bringing down just the subset of data that you're really interested in, and also temporal data, which is a very interesting area as well. So I think we're at time, and there's a lot left in the next session. The remaining slides are really just about what's different in OData version 4 versus OData version 3. But since there didn't seem to be a lot of people who had a lot of background in OData version 3, we'll cover a lot of that when we get to the next presentation anyway. So I'll take a few minutes for questions if people have questions at this point. And if not, we'll jump into the next session. My short answer would be yes, it would be. It'd be qualified with the amount of data and how quickly you needed to transfer it. So it is an HTTP, sorry, can't talk today. Unfortunate day not to be able to talk. An HTTP, there might be too many T's there, based protocol. That said, there's really two parts of OData. One part is the protocol, and the other part is the format. And we have two different formats defined for OData today. We have an Atom-based format and a JSON-based format. And the JSON-based format is by far the more popular now. And in fact, the OASIS version 4 specification, the JSON format is a final ratified standard. The Atom format is still in a committee specification state, awaiting 2 more implementations. You have to have 3 implementations to progress to a final standard. So the rest of the OData specification had, including JSON, had 3. The Atom only had 1. So one of the things that I anticipate happening over time is for us to plug other formats in. And so OData being just a HTTP-based protocol uses just HTTP content negotiation. So the client specifies in the accept header, these are the formats that I can accept, and then the service is free to pick any of those and to return along those lines. And that's how it can determine whether to return Atom or JSON or the one of its choice. We've been talking about other formats as well, and one of the formats that we've talked about is a binary format. And so you can use the same protocol, the same schematized mechanisms and so forth, but you can do it with a much reduced transfer cost because now you're transferring binary data. And in fact, we've done some prototyping of a binary protocol that is very, very fast exactly because we have the metadata that describes the types that we are exchanging. So that helps us optimize the buffers that we build and the code that we build to do the binary data exchange. So that's a long-winded answer. The shorter answer is if you have business to business and HTTP is a viable pipe for you, then OData is a viable solution for you. If you have a way to exchange binary data between yourselves, then you can still use the protocol and do content negotiation for other formats. Yeah?
Is there a mechanism to externalize very large binary objects like files, so that it only contains the URL to the entity or to the file?
Excellent question. The answer is yes. OData, in addition to supporting binary properties, also supports stream properties. And we have two different types of stream properties. One is based on Atom media resources. And a media resource is basically a resource that says, this is fundamentally a picture or a movie or something very large. And the stream is fundamentally what the entity is about. It also has some properties associated with it. And so I'm going to create this stream, and as a result, I'm going to get back a resource that now I can add properties to. And I can interact with the properties, or I can read and write that stream. So that's what we call a media entity in the OData world. And that's where the entity itself represents that media, that large stream object. The other scenario is I have multiple different streams. So fundamentally, I'm an employee record. And so the properties really are first class, but I've got some other large properties, like I've got a photo, and I've got my resume, and maybe I've got a little YouTube clip of myself doing something that I think will get me hired. And those things can all be associated with the entity as stream properties. And so those stream properties are returned as URLs that you can go then use that URL to get that stream.
Do you already support OData in SharePoint? So can I access SharePoint files, folders, sites via OData?
OData does support, or SharePoint does support OData. So you can interact any 2010, 12, any recent version of SharePoint you can actually interact with as an OData service.
In 2010, we could pull this data, and in 2013, we get the
Okay, and is it complete enough to really replace other interfaces, or can I really get every object and perform every action on a file, like check out, check in, or?
So OData is not intended to be necessarily replace all the functionality of an API. So for instance, coming from a SQL background, the OData query language is not as expressive as the SQL language. It's getting pretty expressive, but from the very beginning, we were very restrictive on what we added to the OData query language because we wanted to keep it simple. And so we said that we only wanted to add things that we really had solid use case scenarios for. So for instance, well, it's no longer true. For a long time, there were no joins in OData. And we could get away with that because the entity model had the first class representation of a navigation path. And most of the types of things that you would do joins in SQL, you didn't have to do joins in OData because there were these natural paths. But there are certain things with correlated subqueries, or if you didn't define up front, if you had two different data sets that didn't have a relationship defined between them, where you might want to combine them and join between them. Now that's, in that particular example, we actually have added cross-join capability in OData version 4. But it was never the intention to replace SQL as a language. It was intended to be a great API for applications to be able to interact with data in rich ways and to select the right subset of data that they needed to do their work. So in many cases, like with my application that I was building for my registration, it did everything I needed. There wasn't another API. I didn't need another API. But I don't expect that in the future, SQL Server will no longer support SQL. And will only support OData. Okay? In that case, I don't know, do people need a break or should we jump right into the next session?